Hello students, in this video we will learn about mass density and we'll discuss how to calculate area and volume. Physical quantities. In science, a quantity that can be measured is called a physical quantity. Example, volume of milk in bottle, distance between our home and school, and the weight of your body and many such things. Two types of physical quantity. There are two types of physical quantity, fundamental physical quantity and derived physical quantity. So what is fundamental physical quantity? The basic quantities that do not depend upon any other physical quantity are called the fundamental quantities. There are 7 fundamental quantities. They are length, mass, temperature, time, electric current, luminous intensity, and the amount of substance. Derived physical quantity. Physical quantities that are derived from one or more fundamental quantities are called the derived physical quantities. Area, volume, and speed are some derived quantities. For example, to know the speed at which an athlete runs, we need to know both the length of the track and the time that the athlete took to reach the finish line. So the speed is derived from both length and time. Volume is calculated by multiplication of 3 sides and area we calculate by multiplication of 2 sides. So these all are derived quantities. International system of unit. 7 fundamental quantities in the SI are given in the table. Their unit and symbols are also given. We should understand the standard convention for the uses of SI units. Units and symbols are the same in all languages. The name of units are written in lowercase. Symbols are written in lowercase except when the unit is derived from a proper name. Few examples are Newton, capital N, and we use capital K, Kelvin, capital A for ampere, as they have been derived on the name of the scientist. Never use a dot after a symbol. We cannot write m dot, kg dot, s dot. And symbols are never written in plural. For example, we write 1 meter, 100 meter, not 100 ms, and not 65 kgs, 65 gms. Only we use g for gram. In this table, we have given some important relationship when we need to convert our units from one measuring system to other measuring system. Considering the fundamental quantities as length, mass, and time, 3 systems were developed. These systems are FPS system, where length is measured in foot, mass is measured in pound, and time is measured in seconds. CGS system, where length is measured in centimeter, mass in gram, and time in seconds. MKS system, length is measured in meter, mass in kilogram, and time in seconds. Area. Any flat closed figure that can be drawn on a plane surface is called a plane figure, and the amount of surface or space covered by plane figure is called its area. The shaded regions enclosed in the diagram here are the areas of the respective figures. The area of the regular geometrical shapes can be easily calculated using some simple formula, and these formula for some shapes are given here. For a square, it is side multiplied by side. This formula we use for calculating area of squares. For rectangle, it is length multiplied by breadth. For triangle, half multiplied by base multiplied by height. For circle, pi r square, where r is the radius of the circle. For parallelogram, it is base multiplied by height. The unit of area is unit of length multiplied by the unit of length. So it is a square of the unit of length. The SI unit of length is meter. So SI unit of area is meter square. We must be very careful when converting the units of area. For example, 1 meter is equal to 100 centimeter, and 1 meter is square is equal to 100 centimeter multiplied by 100 centimeter is equal to 10 to the power 4 centimeter square. Measuring the area of irregular shapes. Certain objects that do not have regular shapes, so we cannot determine their area by using a formula. We can calculate their approximate area by using a graph paper. Let's take an example here. We measure the area of an irregularly shaped leaf using a graph paper. And the procedure is place the leaf on the graph paper and trace its outline. Count the number of the complete squares within the outline. Here we have shown these complete square by this right mark, and also count the number of incomplete squares that are half or more than half. We will not count these squares here as they are less than half, and put the number of count in this formula. So the formula is the area of figure is equal to 1 multiplied by the number of complete square, unit is centimeter square, plus half multiplied by the number of half or more than half square. Here 21 are the number of complete squares and 9 squares are half or more than half. So it is 1 multiplied by 21 centimeter square plus half multiplied by 9 centimeter square. It is 25.5 centimeter square. Volume. The total space occupied by a substance, solid, liquid or gas, is called its volume. For example, when you fill water in a bottle, it occupies a definite space in the bottle. This space represents the volume of water on the bottle. Unit of volume is equal to unit of length cube. The SI unit of length is meter, so the SI unit of volume is meter cube. The volume of regular solids can be found using the formulas. Here we have given some formulas to calculate the shape of some regular shaped objects. Like for cube we use this formula, side multiplied by side multiplied by side. For cuboid it is length multiplied by breadth multiplied by height. For a sphere it is 4 by 3 pi r cube. This should be cube. For cone it is 1 by 3 pi r square h. For cylinder it is pi r square h, where h is the height of the cone and cylinder. The relationship between SI and CGS units of volume. 1 meter cube is equal to 1 meter multiplied by 1 meter multiplied by 1 meter. So this is the way we convert unit from meter to centimeter. So it should be 10 to the power 6 centimeter cube. Here 1 liter is equal to 1000 milliliter, and also 1 liter is equal to 1000 centimeter cube. So 1 milliliter is equal to 1 centimeter cube. Measuring the volume of irregular solids. The volume of irregular solids can be measured indirectly using a measuring cylinders. Because the objects that do not have easily measurable dimensions, it is not possible to measure their volume using formula. So we use indirect method to measure their volumes. Now let's take stone as object. Take a piece of stone, a measuring cylinder, thread of sufficient length and water. Place a measuring cylinder on a flat horizontal surface and fill it partially with water. Now note the reading of water level, initial reading. In this case it is 60 ml. Initial water level is 60 ml. Now tie the piece of stone with a thread and dip it completely into the water. The level of water rises. Note again the reading of water level. Final water level is 80 ml in this case. The difference in the initial and final water level readings gives us the volume of stone. Volume of stone is equal to final water level minus initial water level. It is 20 ml in this case. Now the mass of an object is the amount of matter it is made of, and density is a property of material. It tells us how concentrated its mass is. So the density of any substance is defined as a ratio of mass to volume. Density is equal to mass divided by volume. It is given here by rho. The symbol of density is rho, is equal to m for mass and v for volume. SI unit of density is kilogram per meter cube. In CGS system, the unit of density will be gram per centimeter cube. So make sure while solving some numerical problems, because the unit will be from same measuring system. Either it should be kilogram per meter cube or it should be gram per centimeter cube. Now if you have 15 kilogram of cotton and 15 kilogram of iron bar, the density of cotton will be more or the density of iron bar will be more. So the answer is definitely the density of iron bar is more, because the volume occupied by 15 kilogram of cotton will be much more as compared to the volume occupied by iron bar. Here we have to give measuring instrument for each of these quantities given here. So we measure mass using balances and scales. For measuring length, we use ruler and measuring tape. We can measure volume using beakers and measuring cylinders. And for time, we use analog and digital clock and stopwatch. To find the density of a substance, we need to measure the mass and volume of a sample of the substance. Write the equation that link these three quantities. So density is equal to mass divided by volume. This is the equation which links density, mass and volume. The unit of density depend on the unit we use when measuring mass and volume. So here you have to give the unit of density. Definitely in this case it will be kilogram per meter cube, or here it should be gram per centimeter cube. Name two instruments that use for measuring small length: vernier calipers and screw gauge. A tap is dripping, the drops fall at regular intervals of time. Describe how would you find an accurate value. Since the drops fall at regular interval, we should calculate the time difference between any count of drops and divide that time by number of drops. Let's assume 10 drops. So time between drops is equal to time difference between 10 drops divided by 10. Use of a stopwatch is suggested to reduce possible error in recording time. An ice cube has the following dimensions. Its mass is 340 gram. Calculate its volume. Volume is equal to length multiplied by breadth multiplied by height. All dimensions have been given in centimeter. So volume is equal to 369.6 centimeter cube. Calculate its densities. Mass is given in grams. So density is equal to mass divided by volume. It is 0.919 gram per centimeter cube. A student is collecting water as it runs into a measuring cylinder. She uses a clock to measure the time interval between measurements. The level of the water in the cylinder is shown at 2 times together with the clock at these times. Calculate the volume of water collected between these 2 times. Volume of water collected in measuring cylinder 1 at time T1 is 15 cm cube and at time T2 it is 70 cm cube. So water collected between these two intervals is 70 centimeter cube minus 15 centimeter cube, 55 centimeter cube. And the time interval is T2 minus T1. It is 43 minus 12 second. 31 second is the time interval. Here student is measuring the density of liquid and some observations have been given. You can pause the video and read all the observations here. Mass of empty cylinder and mass of cylinder plus liquid is given. So we can calculate mass of liquid by subtracting these two observations. So mass of liquid is 56 gram. Now volume of liquid is given. So we can calculate the density of liquid using the formula density is equal to mass divided by volume. It is 0.949 gram per centimeter cube. In this question, the sports hall dimensions have been given. So the volume of the hall will be the multiplication of these three sides. It is 48000 meter cube. The volume of the hall is equal to the volume of air present in the hall. So calculate the volume of air in the sports hall. It will be the volume of the hall. Calculate the mass of the air. Since density has been given, so we can calculate mass by rearranging the formula. Density is equal to mass per unit volume. So mass is equal to density multiplied by volume. So it is 62,400 kilogram. In this question, the measuring cylinder 1 represents the volume of water. So let's say V1 is equal to volume of water 70 centimeter cube. It is 70 here. And measuring cylinder 2 represent volume of water plus a pebble, a rock sample inside a measuring cylinder. So this is 95 centimeter cube. Now volume of rock sample will be subtraction of these two observations. So V2 minus V1 is equal to 15 centimeter cube. And density we know it is mass divided by volume. Mass is given the rock sample. A has a mass of 102 grams. So density is equal to 6.8 gram per centimeter cube. The table shows the student reading for samples B and C. So copy and complete the table by inserting the appropriate column. As this mass is of rock sample B, between these two values we know that V2 will be greater than V1. So V2 is 80 and V1 is 44. the volume of rock sample B will be V2 minus V1. It is 80 minus 44, 36. And density is equal to mass divided by volume. So 144 divided by 36 is equal to 4 gram per centimeter cube. Similarly, for rock sample C, V2, which represent volume of water plus rock sample, it is 124, V1 71, V is V2 minus V1, 124 minus 71, and density is mass per unit volume, 166 divided by 53, it is 3.1 gram per centimeter cube. A flask with a tap has a volume of 200 centimeter cube. When full of air, the flask has a mass of 30.98 gram. When the flask is connected to vacuum pump, the air is pumped out and the tap is closed. The flask now has a mass of 30.72 gram. Calculate the mass of the air in the flask before connecting to the vacuum pump in gram. So mass of flask with air is 30.98 and mass of flask without air is 30.78. So mass of air will be the subtraction of these two. Observation, it is 0.26 gram. Now volume of air is equal to volume of flask. It is given 200 centimeter cube. So density of air is equal to mass divided by volume. It is 0.0013 gram per centimeter cube. Volume of stone is to be found using the equipment illustrated. And you have to add the appropriate words here to complete the sentences which make sense. Pour some water into the measuring cylinder. Take the reading of the water level, mark as reading A from the scale on the measuring cylinder. Carefully put the stone into the measuring cylinder. Take the new reading of the water level, mark as reading B from the scale on the measuring cylinder. Calculate the volume of the stone by subtracting reading B from subtracting reading A. Thank you for watching this video. Please write your feedback in the comment section. And I again advise you to please pause this video and try to read every single word on each slide what is written here. It will help you. Thank you once again.